around the nucleus, around the nucleus. Due to this motion around the nucleus, due to this motion, orbital motion and spin motion, the electron, what we know, electron has permanent spin and orbital motion, due to which it has a small magnetic moment, of the order of 9.27. It is very small, 9.27 into 10 to the power minus 24 ampere meter square. Why it is so? Because we know when a charged particle is there, and when a charged particle is in motion, then a magnetic as well as electric field is associated with it. Why? Because we know when a charged particle is in accelerated motion, then it has both electrical as well as magnetic field. The unit of magnetic moment is Bohr magneton, represented by mu b. Based on the magnetic property, the substances are categorized as what? They are categorized as diamagnetic, ferromagnetic, periferromagnetic, and antiferromagnetic. Based on their behavior in the magnetic field due to difference in the orientation of the electron. Let us discuss them one by one. Let us see. Based on the magnetic property, they are classified as, the first one is paramagnetic, the next one is diamagnetic, the next one is ferromagnetic, the next one is periferromagnetic, and the next one is antiferromagnetic. So the first we will discuss what is paramagnetic substances. Paramagnetic substances, these are the substances which has unpaired spins. That means they have unpaired spins due to presence of unpaired electrons. When they are placed in the magnetic field, then they are magnetized in the same direction to that of electric field. It means these are weakly attracted by the magnetic field. To the next, when they are removed from the magnetic field, then they lose their magnetization. This is all about the paramagnetic substances. What is that? So first one, paramagnetic. These are weakly attracted by the magnetic field. The next one, these are weakly attracted by the magnetic field. They magnetize in the same direction to that of magnetic field. The third one, they lose their magnetization when they are removed from magnetic field. The next, they have magnetic property. They have poor magnetization due to presence of unpaired electrons. For example, we have O2, Cu2 plus, Fe3 plus, and Cr, chromium 3 plus. What we know? In paramagnetic substances, these are weakly attracted by the magnetic field in the same direction. They lose their magnetization when they are removed from the magnetic field. They have poor magnetization because of presence of unpaired electron. For example, we have oxygen, copper 2 plus, chromium 3 plus, and iron 3 plus. The next we will discuss diamagnetic substances. These are the substances which are weakly repelled by the magnetic field because they are magnetized in the opposite, they are poorly magnetized in opposite to the direction of magnetic field. Why it is so? Because in this case, in this type of substances, the spins are paired. It means they have not unpaired electrons. They have pair electron, therefore the spins of one electron antiparallel to another therefore cancel out each other, and they are termed as diamagnetic substances. What we have? These substances are weakly repelled by magnetic field. The next is that they magnetize, they are poorly magnetized in opposite direction to that of magnetic field. Why it is so? Because in these substances the electrons Electrons are paired. The electrons are paired, which cancel out the magnetic moment of each other. This is all about the diamagnetic substances. We will discuss ferromagnetic substances. But what we have discussed in the previous section, that is diamagnetic substances, they have pair spins, therefore the magnetic moment cancel out each other. They are poorly repelled by the magnetic field because of poorly magnetization in the opposite direction. And we have the example, that is benzene, water and sodium chloride of diamagnetic substances. Next to that, we will discuss ferromagnetic substances. As we know, the iron, when it is kept in close contact with the magnet, it develops permanent magnetization. It is an example of ferromagnetic substances. Why it is so? How it happens? Let us discuss the ferromagnetic substances. Ferromagnetic substances. In ferromagnetic substances, they are strongly attracted. They are strongly attracted by the magnetic field. To the next. They develop permanent magnetization. It means on removal of magnetic field, they have magnetic property. Why it is so? Let us discuss. These are, for example, what we have. For example, in case of cobalt, the next one nickel, the next one chromium, the next one chromium, CrO2, the next one gadolinium. In this case, in these metals, the metal ions are aligned in a definite direction. The metal ions are aligned, which are behaving as a teeny magnet. They are aligned in a definite direction. And when they are aligned in a definite direction, they form domain. Due to formation of domain, they have strong magnetic property. On application of magnetic fields, these domains are aligned. On application of magnetic fields, these domains are aligned in a definite direction. Therefore, they have strong magnetic characters. On removal of magnetic field, the domain are aligned as such. Therefore, they develop permanent magnetization. Let us discuss. For example, in case of cobalt, nickel, gadolinium, chromium, the metal ion are aligned in a different direction to form domain. This domain acts as tiny magnet. In the absence of magnetic field, they are randomly oriented. Therefore, the magnetic moment of one domain cancel out each other. In absence of absence of magnetic field, in absence of magnetic field, the domains are randomly oriented. Therefore, cancel out the magnetic moment of each other, and therefore has not magnetic character. But when we apply magnetic field, then these domains are aligned in a different direction. Therefore, they have a strong magnetic behavior, they have a strong magnetic moment. Let us see. It means, but on application of magnetic field, this domain aligned in a different direction, and therefore a strong magnetic moment is developed. On removal of magnetic field, the orientation of domain does not changes. Therefore, they retain their magnetic behavior on removal of magnetic field. What we know, in case of ferromagnetic substances, they are strongly attracted by the magnetic field because they are magnetized in the same direction to that of magnetic field. Why they are strongly magnetized? Whereas paramagnetic substances are weakly magnetized because this metal contain metal ions which aligned in a different direction to form domain. It means a domain constitutes of various metal ions aligned in a different direction and behaves as a tiny magnet. On application of magnetic field, in the absence of magnetic field, these domains are randomly oriented, therefore they will cancel the magnetic moment of each other and hasn't magnetic property. But on application of magnetic field, this domain aligned in a different direction and therefore they have a strong magnetic moment. And after removal of magnetic field, there is not change in the orientation of the domain, therefore they have permanent magnetization. Or you can say they have permanent magnetization. This is all about the ferromagnetic substances. Next to that, we will discuss antiferromagnetism. In that case, such as manganese oxide, the domains are oppositely oriented and they are equal in number. It means the orientation of domain, as in case of manganese oxide, is opposite and they are equal in number. Therefore, cancel out the magnetic moment of each other and therefore they have not net magnetic moment. What we know, that is antiferromagnetism. In case of manganese oxide, the domains are oppositely oriented with each other and equal in number. Therefore, cancel out the magnetic moment This is all about the antiferromagnetic substances, that in case of manganese oxide they have domains as in case of iron, but the domains are oppositely oriented and they are equal in number. Therefore, they will cancel out the magnetic moment of each other, and therefore they have zero net magnetic moment, that is antiferromagnetic substances. In case of ferromagnetic substances, they also form domains as in case of iron. We get in the form of ferrites. In case of ferrites, they undergo domain formation, but they align parallel and anti-parallel to each other. But they are unequal in number, due to which they have some magnetic moment which is lesser than the iron. This is lesser than the ferromagnetic substances. It means they are weakly attracted by the magnetic field, but lesser in comparison to ferromagnetic substances, but greater in comparison to paramagnetic substances. They lose their magnetization on hitting and turn to paramagnetic substances. What we have discussed, that is, in case of ferromagnetic substances, the domains are